Hey learners, back again with another video with the new type of reaction. But we can't say that it is a reaction, we will say it's a type of reaction of nucleophilic substitution which we have done in earlier video. Nucleophilic substitution, we know methyl chloride in presence of nucleophilic reagent was producing methanol. And this reaction was taking place with the help of nucleophile. We know that carbon was partial negative, carbon was partial positive, chloride was partial negative. Then there is the attack of nucleophile, there is a bond formation and bond breaking, and that is the resulting in formation of methanol. We know this mechanism, we have done in earlier video. Today we'll talk about the bimolecular. Why we are saying it is a bimolecular nucleophilic substitution reaction. See what happens, chloride ion here is showing second order kinetics. What is second order kinetics? What happens in second order kinetics? That means the rate of reaction depends upon concentration of reactants, but here depends upon the concentration of both the reactants. They are methyl chloride and hydroxide. So the rate depends upon concentration of both the reactants. That's why we are saying it is following second order kinetics, and we are calling it bimolecular nucleophilic substitution. Okay, in this reaction what happens, this methyl chloride and our nucleophilic reagent, they are taking place simultaneously. Fine, they are taking place simultaneously. This is about the why we are saying it bimolecular. Now let's talk about the mechanism. What happens, how the mechanism is taking place. See what happens, the methyl chloride, methyl with 3 hydrogen, one is below the plane, one is above the plane, and here it is chloride. See what happens, methyl chloride, in methyl chloride the carbon halogen bond, this one, carbon halogen bond, this bond starts breaking and new bond formation takes place. How? Earlier we have done in nucleophilic substitution, same we are having a nucleophilic reagent here, that is the OH negative. Then what happens, this OH negative will attack and there is a displacement of chloride ion, and after that what will get? OH. But where the attachment of OH will take place? COH, bond between carbon and hydroxyl, it will take place here, and due to this attack there is a movement. The hydrogen will get displaced in such, not displaced, will move in another direction in such a way. Earlier the configuration of the compound was in such a way that hydrogen are towards this side, and now the hydrogens are towards that side. That means this is the we can say there is a inversion of configuration. Inversion of configuration, or we can say there is a umbrella. Whenever we are using the umbrella, you represent umbrella, suppose I am drawing it here in such a way. This is your umbrella. Fine. When a storm catches, a strong wind is there, it get revert back. So in the same way your configuration get inverted form. So this is known as inversion of configuration, or we can give a name here. This is also known as Walden inversion. One more thing is also there. See what happens. Whenever there is a formation of this, what happens here? We have here a transition state, 5-membered transition state, which is unstable. Unstable transition state, intermediate between these two. Unstability, due to instability, there is a displacement of chloride ions and there is a movement of inversion of this configuration, and that is resulting in formation of this product. So this is all about. And one more thing is there, that attack of OH negative is taking place from backside. Heavier atom is there, chloride. Attack can't be possible from this side due to steric hindrance. So attack of OH is taking from back side, whereas there are no steric hindrance. Hydrogen is above the plane, one hydrogen is below the plane, one hydrogen is in the plane. So attack of OH negative, this is a lighter element. So attack of OH negative can be possible from the back side, and this results in formation of methanol, and this is known as bimolecular nucleophilic substitution reaction, and this is also known as Walden inversion. Inversion of configuration is taking place in this bimolecular nucleophilic substitution reaction. Okay, why we call it bimolecular? Due to order of kinetics. So this is all about substitution, nucleophilic substitution, bimolecular. Thank you for watching. Do like, share the video.